Good. So just very quickly, a couple of things about logistics, what we're going to do. So we are going to talk, or I'm going to talk about 20 minutes after an hour about TensorFlow 2. Fabian will give an overview about like TensorFlow ecosystem and how he's using in his like daily life. And then I'll talk about what's a TPU and how it's working, and what's TensorFlow and what TensorFlow Lite, sorry, and what are the main components. I'll show you a few demos. So we have hands-on. A part of it is just if you have any laptop you can connect, we'll use Google Colab to convert models with TensorFlow Lite, and that's mostly like 99% of the work when you're doing that kind of things is convert models. So everyone can do that have Chrome installed on any laptop, and you have, I think you can use Google Guest Wi-Fi, right? So to connect to Google Colab. If you want, then there are like boards that we prepared there. At the end, we have like thought, okay, 1 hour, and then you can eat something, and if you want, you can try the boards yourself. We have already put some demos on them that we developed. It's one user at a time, so maybe you can see if you want like a couple, so maybe 2 people try together, you have to unlock, and there are instructions there, and I'll tell you so how to do that. All the slides and code and demos that you see are here available, so you can connect here, and you can find also the slides. There are Google slides, and Fabian's slides will be put there. They're like in PowerPoint, and we will put them later. Just for the people, in the meanwhile, for the people who would like to try to test them, since we have to test them, we have to use the SATA connection. So you will need this driver installed, and if you are using Windows, you need PuTTY. If you have like Linux or Mac, that's fine. So if you go back here, you can find the slides and then click on the link and install it. Because if you don't have this driver, your computer will not see the board. Okay, so just as maybe in the meanwhile, while I'm talking and you want to try, if you haven't, so you can try to install those. It should be rather painless. So that should be rather painless. So first of all, so who am I? And then Fabian, I think, has your slide on yours. So I'm a Google developer expert in machine learning. I wrote 2 books, and I'm teaching deep learning at ZW. And today, so that's how to get in touch with me. If you have questions or anything, you can always like get in touch with me. So what we do is typically, first of all, so let me just tell you something. First of all, I try always to structure trainings in 2 parts, like a bit of theory, so that you understand why we do things and why we do in the way we do things. So why it's interesting, what is the reason why we do things, and then we try things so that you understand, so that why we're doing different things. So you will see that I'll always start with like some part of theory, and then you will have the occasion to use that. And I hope that it will help you understanding that. I'll start with TensorFlow. So how many people have used TensorFlow? Almost everyone. That's good. So, and how many have used TensorFlow 2? Almost everyone. That's good. So you like it? Yeah. So maybe for just to understand the difference, I'll try. Then I can be brief if you have already know everything. But I think that the main point to understand TensorFlow 2 and what's better about TensorFlow 2, you need to understand TensorFlow 1. Okay. I think that Fabian, you'll go through the entire ecosystem. So just to say here at the moment, the TensorFlow goes from like training models to deploying models to serving models on different hardware, like the Coral devices and so on and so forth. There's a complete like palette of everything you need. So, and then I'll probably skip because Fabian, you go through that, right? So the typical training workflow so has different parts, and I think what I like about TensorFlow 2 is that the fact that they develop things just to solve the most common problems that we face with TensorFlow 1. So if you work with TensorFlow 1 and you have cursed TensorFlow 1 because something was very hard, now in TensorFlow 2 probably there are ways of doing that in a much easier way. Okay. And I think that the main thing about, first of all, it's I think now I'm going slightly faster here because I think that you all know. So if you want to stop me with questions or you think that's too boring, just let me know. Okay. So first of all, so TensorFlow, and you can guess by the name, is using tensors as a main data type. Okay, tensor is just a multidimensional array. It's like a NumPy multidimensional array. It's a bit more than that, but basically it's just a multidimensional array that has specific characteristic like name, type. Rank is like the number of dimension, like a scalar, or a 2-dimension is a matrix, 3-dimension is like a cube, and so on and so forth. You can think about, for example, a gray image is like in the MNIST dataset is just a matrix, rank 2 tensor. Color image with 3 color channels is a 3-rank tensor because there's a 3-dimension. Just a vector, a single vector of number is a 1-rank tensor, and so on and so forth. Okay, so the shape is the number of elements in each dimension. I think that's relatively clear. So 28 by 28, the MNIST digit size is, it would be a 2 ranks, rank 2 shape of 28, 28. Okay. There are different tensor types that you can use, that you could use. I mean, they're still there, but not completely visible in TensorFlow 2. And there are like tensors that were constant, tensors that were variables. And if you have worked with TensorFlow 1, you know that the variable, the initialization of variables and all that kind of stuff, that are tensors that change during the training, for example, the weights. So the weights, for example, and the parameters were different kind of tensors that were not allowed to change. Some were allowed to change and were supposed to change. You had placeholders like for the different data set that you were feeding to the tensors and so on and so forth. And in TensorFlow 1, I think one of the main concepts that is many people maybe forget in TensorFlow 2 is the computational graph. Okay, so computational graph, when you were working with TensorFlow 1, what you were doing is you were building actually computational graph, meaning that you were explaining what kind of step you wanted to do in your computation. Right? So you set up your network, or you set up, you multiply two matrices, you're just telling TensorFlow how to multiply the matrices, not to multiply them, but just how to multiply the matrices. And you were doing like this computational graph construction. And that's why, for example, that's visible in the language that TensorFlow is using, because, for example, you use, for example, the word operation in TensorFlow, right? You have a TensorFlow operation. The adding two matrices is an operation, right? You have like, you can plot it like a set of operations, and you talk about, and each operation is like a TensorFlow call to an API, right? tf.add, you add numbers, tf.matmul, and so on and so forth. And the reason why it's so important, because when you create a computational graph, you can actually optimize it quite heavily, and that's what TensorFlow was doing. For example, TensorFlow, so you have a computational graph, you can put specific operations or part of the graph on different hardwares. And so, for example, on the Coral device, you have the TPU, you can ask it to say, for example, oh, I want to load the data on the let the CPU load the data, but the matrix multiplication, I want it to run on a GPU or on a CPU. Okay, so, and this concept, the computational graph, is still there in TensorFlow 2, but you simply don't see that as evident as before. So in TensorFlow 1, you had to construct one, and you had to separate like the running of the TensorFlow, so the actual calculation and the construction of the computational graph, while in TensorFlow 2 happens, everything happens in the background for you. So you don't see it, it's there, but you don't see it, okay? And in TensorFlow 1, you had to construct the graph, and then the meaning that when you actually use tf.add, it added the node to your graph, and so on and so forth, and then you had to open a session, run the calculation you want, or better say, run the operations of the computational graph, and then you had to release the resources, okay? So, for example, if you sum two constant and you wanted to print the result, you would not get the result in TensorFlow 1, okay? Because no evaluation has yet taken place, you have to open a session and connect to the backend that was able to run it, and so on and so forth. So you had to open a session, then run it, and you would get the results 1 + 2. That was what's happening in TensorFlow 1, okay? And that was already something that kind of annoying, because if you are used to like using like Python debugging tool, you get kind of an annoying side effect that you cannot use them as you would use for other code, because the moment that you have to open a session, everything has to be part of the computational graph, otherwise you cannot use it. So if I want you to, for example, to calculate here, I don't know, A times B, right? If it's not in the computational graph, I cannot run it unless I add another node to the computational graph, okay? So T session was this class that was able to connect to the Python code in the runtime and get you the results you wanted. And the other annoying thing that if you work with TensorFlow 1 was that the moment you close the session, you lose everything. So meaning that all the weights are lost unless you save them. in a file or somewhere. So the variables are not staying with you in the entire time. So very often you open a session, you run it, and you close it, and unless you save it explicitly, you will lose like training and hours of training. Okay, so you could do lots of things, and but I think that we can skip it. Now, what's really nice with TensorFlow 2 that people realize that this is kind of annoying, okay, and it's not so easy to debug it because you cannot simply print, for example, during the training loop what's going on. So you can read that, but I'll skip that. So the nice thing is that let me skip to the main thing. Is that first of all they consolidated like the high-level API, and that's using Keras, and that's actually, and I think maybe Fabian will tell a bit more about that, because before you had lots of low-level API that you could use. You could multiply matrices or use dense layers, and they were like kind of they were not so cleaned up, all the APIs that you could use. And now, so they decided to go for Keras, meaning that with Keras, you can do almost everything now. So if you want to do, unless you have to do really low-level stuff, I'm pretty sure that 99% can be done with Keras with different ways, but I'll talk about Keras very quickly. But Keras is now the standard high-level API, is supported, is documented, and you can use that. And eager execution is nothing else than saying that you actually get the results immediately. So if you sum two numbers, 1 and 2, two constant in TensorFlow, you get 3 immediately. So you can build your own training loops. You can build your own custom training loops. You can do whatever you like. You can process the images in ways, or images or data in ways that were not possible before, because before there was this session, this construction, they were separated. And now it was, you can write like networks and train networks in the same way as you would write any Python code. Right? So getting immediately, you had variables, you can check variables with debugging tools, you can follow what's going on with the variables, you can print out different values at different training parts, and so on and so forth, okay? And before it was much more complicated. So if you have never worked with TensorFlow 1 and you're starting and you want to learn, I would suggest to start with the 2. But maybe just keep in mind a few things about the 1 that would be the computational graph is still there, okay? There are a few things like the TF function decorator. If you are like a bit more experienced, if you have seen it before, this also works with the computational graph in the background, compute 1, and so on and so forth. So it's not completely gone, it's simply not so visible anymore. TensorFlow is there already. So of course, you know, and for example, if you use Google Colab, or if you want to install it, you can simply install it. This exclamation mark is just there because if you use Google Colab, you know that you can install packages with exclamation mark. Everyone knows Google Colab, or right? No? So Google Colab, Jupyter Notebook? Yeah, okay. Google Colab is like an online Jupyter Notebook that Google puts at your disposal, and it's gratis, so you can use it, and you have GPUs and TPUs there. And the only difference is that you get your own kind of virtual machine there, and you can install the packages just using the exclamation mark. Is like starting a shell command. So you can install like the last one. You can install the TF Nightly, for example. That's just the last build version of TensorFlow, and I will show you that we will need to do that to test the board. You can install GPU version and so on. You can install different version like any package. Okay. There is a small Google Colab trick, and because Google Colab has both versions installed, the 1.x and this is I think the 1.15, and the 2.1 are already installed. So you don't need to do anything. You just can use this magic command percent TensorFlow version 2.x or 1.x, and it automatically load the 2 or the 1. So when you're playing or trying to do research on Google Colab, you don't need to install anything. You can use those. If you want a specific version, like we do for the Colab devices, you have to install it explicitly. But otherwise, everything is already there. If you have questions, so I'm talking quickly because you told me that you know a bit about TensorFlow. GPU dependency, so you can check those. So if you have like a server, like a Linux or where you have NVIDIA graphic cards and you want to use them, they're supported. There are some requirements that you have to go through. If you want to use GPUs but don't want to go through that, you can use Google Colab because you get free GPUs and they make a big difference. So if you've never seen that, try to train the same network with a GPU or without a GPU on a Google Colab, and you'll see a big difference. And we're talking about like 20, 30 times faster sometimes, okay? If you have questions, any question or something you don't know, just stop me, okay? So you can always check the version. It's like the typical Python _ version __. And we would use that because sometimes specific features are only in specific versions. So I tend to put that at the beginning of my Jupyter notebook to make sure and to remember which version I was using, because sometimes things change and then nothing works anymore. I'm sure you've seen that before. So again, so as I said, so your execution goes in this direction. I add the number and I get immediately the result, so that I can really like compute custom training loops very, very easily, kind of very easily, but relatively easily. Okay. And then of course there are the classical, like they remove duplicate functionality, they remove like unclear like call names, function names, and stuff like that to make it more consistent, and so on and so forth. And I think that Fabian will surely tell more about the ecosystem, TFX, and the other parts. You have still access to all the low-level stuff, so you can really like write a matrix, like write a network with multiplying matrices if you want. Don't have to. If you want, you can do that. It's kind of instructive, but with Keras, it's kind of not necessary anymore. If you're interested in how to, like, in which order you should like get like try to understand different parts of TensorFlow, I wrote there is a markdown file that you can check that where I try to put down the order in which you could actually try to learn the different parts. So from the most like easy stuff to the more like complicated stuff. And you don't need everything at the beginning, of course. You can do a lot and learn a lot just by starting. And you will see that, for example, the demos that are on the board are like, I try to develop them with using so few functionality as possible so that you can concentrate really on what the TPU is doing and not on other parts that may not be clear. So in using TensorFlow. You can use in TensorFlow, it's as easy if you use the sklearn. It's like the same kind of functionality. You just have like you define the architecture, and we'll see an example later. And you can simply use a fit function that you give the data and the number of epochs, and it will start training, and it will shoot. I mean, if the network is designed well and the data is the right shape and the labels are okay and all the kind of stuff that you should do, it should learn something, and you should get a model that predicts something. So that's that easy. That's all the kind of training the line that you need to type in Keras to train a model. Okay. You can do also stuff like yourself, like really asking Keras to calculate gradients. If you know like that you use gradient descent, you know that you need gradient to calculate to update the weights, right? So for the optimizer, you can also ask like Keras to calculate the gradients, define functions. You can define your custom loss function and do it really step by step yourself. And that's only possible because you kind of put that in a loop and you do that one time after the other. So you have like this kind of extremes where you go from here where you don't have any control at all on what's going on. So it's up to Keras. You have no way of knowing what's going on. To here where you can start, for example, using gradient clipping and stuff like that and checking. And instead of calculating the gradient, you can even like define functions and define it as a class that with a gradient function so that you return the gradient in a form that is numerically stable, for example. So you can do lots of stuff that otherwise would be impossible with this way here. Okay, so you may imagine there are like functions that are kind of sensible, like to big or small numbers, and you can define them in a more smart way or write them in a more smart way, simplify them mathematically, and you can do all these kind of things or this kind of stuff if you want that too. So that's really flexible. Again, so maybe what's eager execution is simply like, I'll not read the slide, but the idea is that really when you write something, it will execute immediately and you get the result immediately. Okay, and that's if you remember, I mean, if you have followed the evolution of TensorFlow when it started coming out 1.13 and 1.14, you could enable eager execution also there, but it was something that you had to do explicitly. And while in 2.0 is like is there, so it's much easier. Again, you can be like custom training loops, stuff like that. It's easier to debug. You can print print is probably not the most advanced debugging tool, but probably the most used one. So you can print out stuff that to check. You can use debugging tool. Natural control flow, it means that you can use for loops and while loops and stuff like that to check what's going on. There is a much nicer also TensorBoard integration. For example, now it's possible to use TensorBoard in Google Colab if you want without installing anything. So all the kind of things make using Keras really, really easy. Okay. Again, so you get immediately the result. Okay, so you can multiply. This is a dumb matrix, I agree, but you get the idea. So you get the results immediately. And for those who are maybe slightly more advanced, and if you start studying TensorFlow 2, you will read the sentence, no more sessions, use functions, or something on that line, meaning that you don't need, so the idea is to have function that does stuff. And you can actually, the problem with functions is that it's very difficult for TensorFlow to optimize it. And that's why you get this kind of TF function decorator that you can use. That's actually quite hard to understand, but the effect is that it will modify the computational graph in the background at the right nodes so that it will become actually optimized and can put it on different hardware. And you get sometimes even 10 times faster execution just by putting these kind of things there. It's not easy to use. There are many subtleties that are not so easy to understand, but the idea is that what the TensorFlow team are trying to do is to make it like, you should bother just writing the functions that you would for any like normal Python code, and then say, okay, now I want to make it, I want TensorFlow to optimize it, so with just a decorator, you just got the all-around things that you need to make it as efficient as possible. So all the changes that you will see in TensorFlow 2 and the new things are typically, in my experience, all coming from annoying things that you had in TensorFlow 1 that were very difficult to do. So my suggestion is sometimes when you don't know if you need something, you probably don't. Because you realize that you need something, you realize you plan, you find very quickly what the solution is. You have any questions so far? Good, so Fabian, just give me 5 minutes and then I'll give it to you. So Keras, maybe for you, TensorFlow decided to use Keras, and maybe just for clarity, you will find the keras.io website. That's the reference implementation. That's not the TensorFlow implementation. The TensorFlow implementation is a superset of the Keras reference implementation, meaning that they've taken the reference implementation, implemented everything as they decided, and then added a few features, okay? So those are two different things, okay? So this one can work with Theano and with other backends. This is TensorFlow. Okay, so there's slightly, so the Keras works the same, but they're not the same implementation. Okay, just as a note. So when you see this one is not this one, so TensorFlow is a different thing. And Keras works like always have the same kind of philosophy. It's very easy to use. So you define a model, and you define it in a sequential way, meaning that you know a neural network is typically a sequential set of layers, right? So the dense layer or convolutional layers and so. So you define a model with a specific syntax, then you compile, and here you tell Keras, for example, which optimizer you want to use, which metrics you want to use, which loss function you want to use, and so on. So you give the Keras the information about how you want to train the model, and then you feed the model, meaning that here happens to train. Okay, and that's the most easy way of using Keras, and that's something that we remain. So you get you will find it over and over and over again, unless you write your own training loops. Okay. For example, the sequential model is actually quite easy to understand. So you get like the TF Keras layers, and you get, for example, a dense, just a set of neurons. You give the number of neurons, you give the activation function, and that's it. Okay, you don't even have to bother thinking about anything else. Dropout, if you know what dropout is, it's a generalization. So regularization term, and then you can imagine that this is a classification network. You have 10 classes with the softmax at the end, right? And that's all you need to do. So basically, that's all the code that you need to build the network. Give it like how you want to train it and train it. That's as easy as it gets. Okay, so with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, and you can probably reduce it if you put some parentheses up. So that's all you need to do. Okay, if it trains is another question, but just to define it, it's actually very, very easy. Okay, you have different loss function, you have different optimizers, RMS prop, Adam, gradient descent, and so on and so forth. But basically, you can simply, and you notice that, for example, it makes really easy for you. So Adam is just a string. For example, you don't have any way of setting the learning rate. Just as an example. You may not need to, because it will choose probably standard value. If you want to, you can do that. You have to go a bit step, but basically it's so easy that you can use a string and it will use the standard value, and you don't even have to know which parameter you need to set, basically. If I tell you use Adam, it's a good idea, right? You can do it like with the class where you like define, you can go like, do it in different ways, but that depends on the level that you are with Python and what you need to do. And just maybe I'll just go slightly quickly. The sequential model, you get different kind of layers. You can use the .add method, for example, if you like, if it's a very long convolutional neural network and you don't want to have these parentheses and then 25 or 50 lines, you can do that this way, for example. That remains regarding if you use .add or like you do, like you put in the constructor here. The feed remains, that's the same. You have lots of layers that you can use. Okay, you don't need to program anything. You can use dense, convolutional, max pooling. Flatten is, for example, when you have an image as the input and you want to convert it to like a long line of pixel values. You don't even have to do that before. Before it was annoying, you had to take the images to a reshape, 1,784 if you work with MNIST and so forth. Then you can put this. So the thing that you start realizing is that Keras is considering everything a layer. So you start, if you think about Keras and every operation that transforms a tensor in another tensor as a layer, you start understanding how Keras is working. Okay, because you can think this is not a neural network layer flattened. It's an operation that you do to transform your data in a more usable format, but it's not a layer. For Keras, it's a layer. So for Keras, a layer is simply everything that converts a tensor in another tensor. So you can start thinking an entire network is also a layer for Keras. So you can download the pre-ready network and put it in your network as a layer, even if the pre-ready network that you have downloaded has 25 layers. Layers in the sense of like lines of neurons. Okay, so if you think that in this way, you understand also why the sequential and why this one, because each portion is like changing the input into the output. The second layer will take the output and transform it into the other output. And then you will understand immediately why, and then let me skip just quickly at exactly in the functional API, because you can use the layers as function on the input. If you think about a layer as a transformation of a tensor in another tensor, you understand very easily this kind of way of writing networks. Okay, so this dense is just a transformation, regardless of how you imagine that, neurons, or if it's a convolution, or if it's a pooling, or if it's a flatten, it will change the input into an output. Okay, and that's way of doing things. It's very nice because it will allow you to do, for example, multitask learning where you have different branches, because you can actually do whatever you want in this form. You can build complicated networks, ResNet, where they are skipping like layers and stuff like that. You can do all you need with this kind of way. So the sequential is for beginners, but otherwise you can do lots of things. You will realize, for example, very easily that I'm sorry, Fabio, try to move faster. You will realize very easily that this simplicity comes with a downside, that is that you don't have much control on what's going on. You have a verbose, for example, to get logging, and if you choose verbose 1, it will log you 1 every single epoch. Every single epoch you get some output. Train for 10,000 epoch, you get lots of output. Okay, and it bogs you down your Jupyter notebook, or it's annoying. So if you want to do specific things at different moment, you cannot do that with that simply, but you can, for example, use what's called, for example, custom callbacks. That meaning that Keras gives you the possibility of calling function at different points in training. When it starts, when an epoch starts, when an epoch ends, on a batch, when you're doing mini batch, you can print output, you can normalize batches, you can do, there are like lots of, for example, lots of things that are already there, like for example, you can change the learning rate, you can decide to terminate or not a number. Anyone who's trained a network and has never got not a number is not really trained a network, so you should suffer through that. And if you get the not a number and you're not checking the results of the loss function, and after 3 hours, you see that after 2 hours 50, after 10 minutes, you start getting not a number, is not very nice. So you could say, you know what? You can put that. So as soon as any not a number appears, that means that nothing will work anymore. It will stop the training. Okay. So it's something that it's nice to have, and that's why it's here, because probably someone cursed quite a lot against that and decided to do that. So you can build your own, but you have like lots of things like early stopping, if you know what early stopping is. You can, one of the nicest one is probably the model checkpoint that saves the model every time it gets better. It saves it. So the server crashed. Oh, after 2 days of training, but you still get something saved. Okay? And you don't have like to save it manually. It just say, and you don't want to save every epoch. If you train every 10,000 epochs, something like with 11 million parameters, it gets quite big, quite quickly. So you just want to save the model only when it gets better. If it gets worse, you don't want to save it, right? And you can simply give it like callbacks in the feed part. The functional API, I told you that. So what's the idea behind it? We'll skip that because we'll talk about that later. That's something else that you can do, for example, very easily. Like you can also, for example, in Keras, decide to like freeze layers, train only some of the layers, download layers, and take out layers. It's simply a sequential set of steps that you can add, remove, and you can play with that a lot. So you can do lots of things with Keras. So it gives you really like lots of freedom in trying to do things. And it's really like consistent now in the way that you use the code. So it's actually quite nice because you start really doing that always in the same way. Do you have any questions so far? That was very quick because you told me, you know, and Fabian will also tell more. So do you have any questions? Surprise, or you knew all that, or kind of? Yeah, okay, yeah. When you've tried it, when you've tried, no? I did make it public, but I'll check it like in a, because before it was not public, but here now, just a second, because I did, now it should be, maybe refresh it, because it was not public like this morning, but now it should be. Okay. Okay. Okay, let's do it this way. So I'll open it then in a minute, and then